this, we have example number 2 for analysis, structure matrix analysis for trusses, determinate and indeterminate. So for temperature changes, if a truss member having a length L is subjected to temperature increase or decrease, that will then be classified as change at the length of a member with regards to the temperature or delta T. The member will now undergo an increase or change in length, which is simply equal to alpha, or the coefficient of thermal expansion, times the change in temperature times the actual length. Okay? Where alpha, again, is the coefficient of thermal expansion as identified on a specific material. A compressive force of QF applied to the member's length, which is delta L prime of QFL over EA. So, ang kukunin natin dito at this time is the change in force along a member which experience change in temperature with regards to its change in length as well. No, if we equate this to displacement, then the force Q is now equal to EA alpha delta T. Okay? This force will hold the nodes on member fixed points. So as we have now the equivalent force or the additional force needed para mag-fit or para pumasok yung ating steel member with regards to the thermal expansion, that is now Q of EA alpha delta T times the matrix of positive 1 times negative 1. So from last meeting or from the previous example, remember, that is delta L, EA over L times delta L. That is only due to the fabrication error. But with regards to the change in temperature, papalitan lang natin yon, which is EA alpha delta L. Then, ganun ulit doon sa ating global structure matrix, global coordinate matrix using the change in temperature. We have EA alpha delta T of positive cosine theta, sine theta, negative cosine, and negative sine. Okay? Don't worry, I'll be uploading this series of Excel sheets. Nakalock nga lang yung formula para makita ninyo kung paano siya, no? So, with that note, using the same example that we've had from the previous examples, from example 2, 3, and 4, ganun ulit. Kaso nga lang with the involvement of temperature changes. Okay? This time, you're now asked to determine again the joint displacements, member axis forces, and support reactions for the plane truss as shown. Due to the combined effect of the following. A, the joint loads. Combined effect. So, yung example 4, wala tayong applied load. This time, considering the applied load and the change in temperature. The increase in temperature of 70 degree Fahrenheit for member 2 and a drop of temperature of 30 degree Fahrenheit for member 5 para magkaiba. Using matrix stiffness methods, having the coefficient of thermal expansion equal to 1.3 times 10 raised to negative 5 per degree Fahrenheit. So, same solution lahat. From member 1 up until to member 5, kunin lang natin muna yung local stiffness matrix according to the designated and specified near far nodes. Your number of nodes, your number of elements and members. So, alam na natin yan. Identify the local stiffness matrix of each members, the transformation matrix for each members, the global stiffness matrix, and the properties of each member, such as shown. And of course, the summary on the structure stiffness matrix for member 1 up until to member 5. So, ito na yung ating ito yung ating structure or general structure matrix of member 1 up until general global stiffness matrix for member 1 up until to member 5. Ganun ulit. So, one thing that is new here is, again, the additional force caused by the change in temperature on member 1 and on member 2. Starting with the member 2 and member 5. Sorry. So, starting with member 5, we have now to identify the equivalent force effect due to the change in temperature of positive 70 degree Fahrenheit, or an increase in temperature with member number 2 of positive 70 degree Fahrenheit. So ano yung equivalent force nung change in temperature na yon with the regards to the thermal expansion? That is your EA times alpha, which is the 1.3 times 10 raised to negative 5, times the delta T, which is the change in temperature of positive 70 degree Fahrenheit. So nilagay ko na dito yung ating 70 degree Fahrenheit, your alpha, which is the thermal expansion, and your EA. Remember, EA hindi EA over L. E times A, the stiffness of the member, modulus of elasticity times its cross-sectional. Remember, the modulus of elasticity is 6,000 h squared times 10,000. Okay? So we have a 60,000 value for E times A. Simplify to give the value for EA times alpha times delta T of 54.6. Then, yan na yung ating EA alpha delta T. Multiply that. That is your scalar quantity. Multiply natin siya sa 2x1 matrix of positive 1 and negative 1. Gives us the equivalent force or the additional force under its local structure matrix, local coordinate system needed na kailangan nating idagdag due to the increase in temperature of 70 degree Fahrenheit. Then we'll have to convert this one with its global coordinate system following the designated near far node coordinates for member 2. How are we going to do that? Multiply the EA alpha delta T, which we have computed here, with cosine theta, sine theta, negative cosine, and negative sine theta matrix as shown. So multiply. Ano yung sine theta ni member 2 at saka cosine theta? Remember, that is 0 and 1. Then multiply both of them with negative 1 to get negative cosine theta and negative sine theta. Then multiply each cell by multiplication of scalar quantity with the matrix with 54.6, which is your EA alpha delta T. So multiply gives us the value or the forces along the global coordinate system due to the increase in temperature for member 2 of positive 70 degree Fahrenheit. Remember the near far node of member 2. Nandito yan. Near far node. That is U3, V8, which is node, node 4 to node 2. Then U1 and V2. So yan na yung ating global coordinate system due to increase in temperature of 70 degree Fahrenheit for member 2. Forces on X and Y axis lang yan. Okay? Same goes with member number 5. Note, with member number 5, it was dictated that there will be a decrease in temperature, pero that would be so unlikely. Kung nag-increase ng positive 70 degree tapos decrease si member 5, pero hindi naman pwede yon. So parang ano lang ito, for the sake of example, para lang maiba. So for member number 5, with temperature decrease of 30 degree Fahrenheit. Remember, decrease ang sinasabi. So basically, delta T should be negative 30 degree Fahrenheit. Yes po. Manual? Sige. Mapapahaba tayo dyan Sige, paano yan kinuha? Suburahin ko lahat ito. Dito na lang ako sa member 5. Burahin natin yan. Tapos, sige, burahin ko na to. Okay. And, okay. So, ganito. So, we have a decrease of 30 degree Fahrenheit, which is negative 30. Okay? known in the problem that there will be a thermal coefficient of thermal expansion of positive 1.3 times 10 raised to negative 0.5. Such as EA of members, meron naman tayong value niyan. That is basically the given modulus of elasticity of 10,000 KSI times 6 inch squared. Okay? Basically, multiply mo lang si E times A. That is, what? 60,000. So, sinet ko na yung aking EA as constant. So, I'll just have to multiply the modulus of elasticity E times the cross-section of member 2. Nakaset kasi yung aking cell. Pinangalanan ko na yung cell ni area at saka cell ni modulus of elasticity. So, that is 60,000. 60,000. So, alpha EA times alpha times delta T. So, equal to this times this times this. That is negative 23.4 EA alpha delta EA times alpha times delta T. Then multiply this one with a matrix of positive 1 times negative 1 and negative 1. So scalar quantity multiply on each cell of a matrix. So that is basically this one times positive 1. Parehas lang. And this one times negative 1. Okay? Then, to compute for the global coordinate or forces under global coordinate system due to change in temperature, that is EA alpha delta T times the cosine theta, sine theta, negative cosine, and negative sine theta of member 5. Punta tayo sa member 5. Member 5. Ayun. Control C. Ayan, nag-choke. Control C. Then, paste lang natin dito only the values. Then, equal to the negative value of cosine theta and the negative value of sine theta. Okay? Then, of course, ilagay na natin siya dito sa additional forces due to change in temperature. These are now your fixed end forces for the member trusses due to change in temperature. Due to change in temperature. Okay? Due to change in temperature, P1 designates the axis force 1 between member 2 and member 5. So that is equal to 0. PF2 is V2. PF3 is U3 plus the another U3 for member 5. I-add mo lang silang dalawa. So enter. Equal to PF4. Walang 4, so basically that is 0. PF5, wala, so 0. 6. PF6. This one, meron pa bang iba? Wala na. Then, 7. Iisa lang. And lastly, 8. And this one. So, dalawa yung ating V8 between member 2 and member 5. And enter. So, yan na ngayon yung ating additional forces in our structure matrix later on due to the change in temperature. Now, conceptualize our structure matrix by the unknown forces or the tawag na dito, reaction forces and the applied forces equal to the structure matrix times the deflection plus the additional forces in our truss system due to the change in temperature. Okay? Due to the change in temperature. Then, yan na yon. Ito yung ating summation like before. Tama? Yan yung summation ng ating member 1 to 5. Then multiply to the deflection and add the change and the effect of change in temperature, which is your PF1 to PF8. Then joint load matrix, ay sabi nga, including including the applied loads. So we know from previous examples that axis force 1, 2, and 3 has such values. Positive 75 kips, negative 150, and positive 150. Such that in a given problem, wala tayong impending deflection. So starting from D4 to D8, as shown in our figure, again, is simply equal to 0. 0 yung horizontal vertical sa node 1, sa node 3, and the vertical at node 4. So D4 to D8 will be equal to 0. Then include the values of PF1 to PF8 which we have recently computed here. Okay? So para okay tayo, tanggalin ko muna to. Ay. Purahin ko lang. And then this one, para dire-diretso. Okay? So computing for the unknown deflections as well as the unknown reactions. Given our formula is the known forces applied to our truss system equal to the structure matrix S11 as shown in our partition matrix here, and the known deflection du plus the structure matrix S12 times the unknown deflection. Saan natin kukunin yan? Remember that we have a three known forces, P1, P2, and P3. Ito yan, di ba? So with that, itapat lang natin yan sa ating structure matrix. Hanapin mo yung 1, 2, 3 na row and 1, 2, 3 na column. That will then be your, ang tawag na dito, that will then be your S11. Then, yung katapat niyang column or the rest of the columns from U4 to V8 will become your S21. Ay, S12. Tama. S12. Then, downward, the other 5 rows will be your S21. And the succeeding columns from that will be your S22. Okay? So, kunin lang natin si S11, which is equal to this one. Copy the entire set, 3 by 3. Then, the unknown deflections, D1 to D3. And the structure matrix from column 4 up until to column 8 of row 1 to row 3. Okay? Then, of course, your known deflection. So, kung yan ay 3 by 5, dapat yung multiplier mo is also a 5 by, basta, conformable yung column with the row. So, equal to zeros, which is this one, D4 to D5. And remember, 3 rows yung pinag-uusapan. So, i-add natin yung due to the change in temperature forces with regards to the 3 rows. Equal to this one. So, 3 rows din doon. Okay? And do not forget your unknown forces, joint load matrix. Okay? So, how are we going to do that? Meron na tayong tatlong values dito. So, para makita natin na ito ay 0, so basically, that is a 3 by 5 matrix times 5 by 1. Gives us a 3 by 1 matrix. Tama ba? Tama ba?
Yes po.
Times a 5 by 1. Control Shift Enter. That is definitely equal to 0. So, tanggalin mo na. Hindi na natin kailangan. So, ito na lang matitira. Si P1, P2, and P3 equal to S11 times DU plus the, kalimutan kong ilagay dito, plus the PF forces. Or the additional forces due to the change in temperature. So, with that, subtract lang natin si 75, negative 150, and 75 with PF1 to 3, which is equal to this one minus this one. Okay? Then, multiply it with the inverse of S11 matrix. Paano yun, sir? So, di ba, tinranspose natin ito dito sa kabila. So, nag-subtract sila, right? Then, divide both sides with S11 matrix. Pero wala namang division of matrix. So, how are we going to do that? We'll just have to inverse the S11 matrix, then multiply it with the difference of this matrix with this matrix. So, inverse lang. So, M inverse of this matrix, Control Shift Enter. And of course, multiply it with the difference of such. Okay? So, a 3 by 1, 3 by 3 times 3 by 1 definitely will give us a 3 by 1 matrix. Ay. Dapat lahat. Equal to the multiplication of the 3 by 1 matrix with a 3 by 3 matrix with a 3 by 1 matrix. Control Shift Enter. So, yan na ngayon yung ating unknown deflection, which is now in inches. Nakuha?
Yes po.
Tomas? Nakuha?
Sir, konti. Opo, konti po.
So, P4 and P8. Nakuha na natin si P1 to P3, which are your known forces. How about the unknown forces P4 and P8? Remember our formula for unknown forces. That is definitely equal now to the structure matrix of S21 times the unknown deflection plus the structure matrix S22 times the known deflection plus the other additional forces due to the change in temperature PF. So, ano dito si S21? Dito yung ating S21. Right? So, kopyahin na lang natin. Then, si S22, which is this one. Then, copy your unknown deflection, yung na-solve lang natin, which is your D1, D2, and D3. Then, multiply this one with D4 to D5. D4 to D8. Excuse me. And lastly, of course, add the forces due to the change in temperature, starting at PF4 to PF8. So if we multiply this one, a 5 by 5 matrix with a 5 by 1 matrix, such that these are zeros, so makakancel na yan. Zeros na yan. So, para isa-isahin natin, multiply natin muna si 5 by 3 matrix with a 3 by 1 matrix. So, 5 by 3 times 3 by 1 is a 5 by 1 matrix. So, this one times this one. Kasi kung imamanual ko pa na isusulat yan kung paano i-multiply, napoko. Abutin tayo ng Christmas. Axis forces pa lang yan. Wala pa yung end joints. Ay, yung end displacements. Then, plus this. No? Okay? Or we could simply do that here. The matrix multiplication of this matrix with this matrix plus dapat lahat. The matrix multiplication of this matrix with this matrix plus this matrix. Kasi 0 na to. Then, Control-Shift-Enter to perform the formula. So, yan na ngayon yung ating mga reaction directed at the supports. Joint 1, 3, and 4. Naintindihan?
Yes, sir.
Now, how about the end displacement or forces on each member? Just like what we did with the fabrication error, idadagdag lang natin with the local coordinate system of a force yung additional forces due to the change in temperature for member 2 and member 5. So, nevertheless, palitan lang natin yung equivalent deflection sa bawat member. Hindi naman na parehas yon. So, with that note, burahin ko to para makita ninyo. Okay? So, sa member 1, we have what? Node 1 to node 2. So, what we have identified before, near far node natin is U4, V5, U1, and V2. Kopyahin lang natin yan. Don't forget, paste only the values kung gusto nyo gumamit ng Excel. Total, dadalawa lang naman kayo. Gumamit na kayo ng Excel. Pero, syempre, i-present ninyo 110. Then, of course, meron bang deflection sa U4 under coordinates, global coordinate system? Meron ba? Axis axis force 4. Meron? Wala. Tayo na-compute dyan. V5, wala rin. Then, we have solved the values of the deflection for U1 and U2, which is here. Ayan. Kopyahin lang natin. Again, remember, copy only the value. Do not paste the formula. Value only. Para magamit natin. Then, solve the, convert into its local coordinate system by multiplying V matrix with the transformation matrix of member 1. Control C. Paste natin dito. Identify the properties of member 1. What are the what is now the length of member 1? That is 192 inches. Cosine theta was identified as 1 and 0. 0 is sine theta. Then we'll have your transformation matrix. Multiply transformation matrix with our V value. Para makita ninyo, dito lang naman yan, equal to multiplication of this matrix. Don't forget kung ano yung nauna sa multiplication natin. Then, Control-Shift-Enter. So, yan na ngayon yung ating equivalent deflection with regards to its local coordinate system. Then copy and paste only the values. Then for our equivalent force at end displacement under its local coordinate system for member 1, basically the local stiffness matrix of member 1, alam nyo naman na yung formula niyan, times the U, yung na-compute nating U ng member 1. So, Control Shift Enter. So, kayo nang bahala kung gusto ninyong gamitin itong conditional formatting ko sa cell. So, if the cell Q1, containing Q1, which is under cell 54 column D, or D54, is less than 0, therefore, this force is in tension. But if it is greater than 0, therefore, it should be in compression, such as shown here. Sana nakikita ninyo. Hindi ko ma-zoom eh. Okay? So, yan na yung ating equivalent force at local coordinate system for member 1. But how about the member 2 where there is an increase in temperature and member 5 where there is a decrease in temperature? So, burahin muna natin mga yan. Okay. So, what is your near-far node condition sa member 2? Member 2 is node 4 to node 2. That is 3, 8, 1, 2. So, copyin lang natin to. 3, 8. Member 2, 1, 2. So, meron bang deflection sa V8? Wala. We have computed the deflection at U1 and V2. So, copy only and paste the value only. Then, na-solve na rin natin yung deflection sa D3. Copy, Control C, and paste only the value. Then, multiply this one with the transformation matrix of member 2. Okay? Tapos, kunin natin ulit yung transformation matrix ni member 2. So, ano yung length ni member 2? 144. Sa cosine theta, 0. Sine theta is 1. Multiply T with the V. Ito yung ating end displacement for member 1 under its local coordinate system. Then, paste lang natin dito as a value. Then, multiply the local stiffness matrix of member 2 times the U value of member 2 gives us the equivalent force. This is just without the, still without the effect of change in temperature pa lang ito So, Control C. Then, paste only the value. Then, this time, we need to add the force or the additional force due to the change in temperature for member 2, which is your 54.6 and negative 54.6. Copy, paste only the value. Okay? Then summate those matrices. So gives us member 2 which is now in compression such that if Q1 is less than 0, therefore it should be in tension. Other than that, therefore it should be in compression. Same goes yung solution ng member 1 with member 3. Near far node, hanapin nyo ulit yung near far node ni member 3, that is U3, V8, U4, V5. Then include which of them has an equivalent deflection. Walang deflection si V8, U4, and V5. So meron lang si U3. Okay. Then same goes with member 4. And lastly, for member 5, solve na rin natin para makita ninyo. Then, paano ba to? So, near far node ni member 5. Member 5. 5 is from node 3 to node 4. That is 6, 7, 3, 8. Okay? 6, 7, 3, 8. May deflection ba sa 6? Wala. Sa 7, wala. Sa 3, meron. Yung kakakompute lang natin kanina. Paste only the value. May deflection ba sa 8? Wala. Maliban na lang kung maglalagay tayo ng impending or known deflection. Okay? Then, copy that. Paste it over here. Identify again the transformation matrix for member 5. It is 240, 0.8, and 0.6. Length is 240. Cosine theta is 0.8. Sine theta is 0.6. Multiply the transformation matrix of member 5 with the end displacement under global coordinate system of member 5. It gives us the u value, or the end displacement of member 5 under its local coordinate system. Then multiply u with the local stiffness matrix of member 5. Okay? Eto. Copy lang natin. And do not forget, remember that member 5 is experience a decrease in temperature. So there will be a additional force for member 5, which we have computed over here. Ito yon. Yung Q1 and 2 ni member 5 due to the decrease in temperature of negative 30 degree Fahrenheit. Then, of course, paste lang natin as a value, then add the LK times U plus QF. So, negative si Q1, then positive si Q2. Therefore, it is now in tension. And again, do not forget to summarize your results. The reactions at the supports, the deflections on each nodes, horizontal, vertical, and the applied forces, and as well the equivalent forces on each member. Then tension, 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 compression. Yun lang naman po. Then what if there will be a settlement or known settlement in each of the nodes? Then combined with the fabrication error, combined with an increase in decrease of temperature, sabay-sabay silang apat sa isang truss. So how are you going to deal on that? Of course, ganun ulit. Kung ano lang yung merong change in temperature, dun mo lang i-apply yung formula na ito. Kung ano lang yung may fabrication error, dun mo lang din i-apply yung formula na binigay natin for fabrication error sa member na yon. Then, kung merong known deflection within an axis force, papalitan mo lang naman yung known deflection ng D4 to D8 or any other axis forces. Then, proceed with the same solutions and formulas. Basically, step by procedural na nga lang yan. No? Question po. Hello?